Hello and welcome back to STEAM with Steve. Today we're going to go through the different data types that are available inside of Python. Now, data type is the way that data is stored inside the program, so then it allows the program to interact with it. So for example, when we store a number, we want to know that it is a number, so then we can add, subtract, multiply, and do all those different operations on it, compared to if it's a bit of text that we want to display. So we're going to go through all the main different types of data types. So there's four main ones that you need to know inside of Python. So there are integers, which are whole numbers. Then there's floats, that are the decimal numbers. Then there's strings, which are the words. And lastly, you've got booleans, which are true and false statements. So to begin, let's jump on in. So the objectives today is to identify and apply basic arithmetic in operations inside of Python, understand and create valid variable names. So we're going to go through that again, and then explain the concept of data types and demonstrate their use inside of Python. So to start, have a go at that. I'm just going to pause the video and see how you go. Awesome. So most of you should have been raging that this wasn't working inside of idle, simply because the naming convention was wrong. So these are illegal variable names. You cannot start with a number. They must start with alphabetical values. So let's change it again. Have a go and see if you can do this one. I'll pause the video there. Fantastic. Let's have a go. So if we go into idle, we're going to store in the values first with the identifiers x is equal to 8, y is equal to 3, and z equals 6. So now if I go x plus y, I get 11. If I go x minus y, I get 5. If I go x divided by y, I get 2.6666 remainder, which repeats on for a while. If I go x into divide y, I should get 2 because that's the whole part. If I go x to the power of y equals 512. If I go x to the power of x, I get a really big number. And I go x minus y divided by z, I get 7.5. And then if we wrap that up in brackets, we get that. Pretty cool. So hopefully you got those. And then we've got this section here. So just checking to see whether or not you'd learned from last lesson what are valid and invalid variable names. So just pause the video and have a go. So the first one, totally valid. Next one's valid as well. So even though it's got a 2, as long as it's not the first character, that's fine. Y is fine, that's valid. If is invalid because that's one of those wholly reserved words. 12 score is invalid because the characters are illegal at the start there. We then have y2, which is valid. 2y, which is invalid. This is valid because you're allowed to use underscore. 2 is invalid. Valid is valid. And then underscore, underscore, underscore is valid, which is pretty bad programming if you do use that. Have a go at this. So this is using camel case, Pascal case, snake case, or not used case. Just pause the video there. Cool. So the first one looks like snake case. So it's got all lowercase with an underscore connecting the words. The next one is then camel case because it's got the first letter is lowercase and the next one is uppercase. And then the next one is Pascal case. Master underscore score is also snake case, so that's valid. Master with no space, with a space in between, is illegal, so that wouldn't work. Mouse clicked is camel case, so it's got a hump in the middle. Increase 1, camel case again. Metal helmet is Pascal case, so all the words that got capital letters. This one is weird, but it would still run, but it's not a case. And then flaming sword is Pascal case as well. So hopefully that's giving you a pretty clear indication of what type of case. Now, this is really important when you're reading other people's code so you can understand what type of variables they're using with their naming convention. So let's jump on in. You have a choice here now. So option 1, you can take the red pill and go down the rabbit hole of understanding how data types actually work, or you can just pause the video, see you later, and stay ignorant to how data actually works. So hopefully we take the red pill and follow Morpheus down into what data types are. So what is a data type? It's the way that data is stored in a computer program. So a computer doesn't understand the difference between the number 1234 and the set of characters 1234. That's what we have to do as a good computer scientist, is to get that context by the way that we use the data type. So we must type the data in a particular way so that it is stored in a particular way so you can access and do different things with it. So first of all, let's have a think about how memory looks. So this is an old school view of some bytes inside of a computer. The blue area represents anything that's been used, and then the white area is anything that's free for the computer to use. So when you see a computer hard drive being filled, basically what happens is you have a certain amount of memory available, and then it gets to a point where it can't use anymore. So there's short-term memory, which is your RAM, and then there's long-term memory, which is your hard drive. So short-term is when your computer is running and doing rendering and gaming and all that type of stuff, whereas hard drive is when you're storing your files or saving your Word documents, and so on. So when we look at something like this, an old image from me doing Kokoda, this is efficient. So the box represents how much memory you have. The image fits inside the box. That is perfect. So it's not too much memory being allocated, but then also not there's not enough sort of space. Whereas the image was only this big, then we would say that there was too much memory that was allocated to the same thing. And similarly, if we went like this, there's not enough memory allocated for the computer to run. So it's really important to work out how to minimize the memory that we use, but then also make sure that we're efficient with the way that it's used. So when we store words and variables and true and false statements throughout the memory, what happens is we need to make sure that the right amount of memory is allocated to storing it. So if we have numbers, there's a particular way of storing that. If we have words, there's a particular way of storing that as well. Now, this is really important as a good computer scientist. And we've got to work out how those memory pieces are measured. And then that's what a bit and a byte is. So basically, a bit is on and off. It says 0 or 1, whereas a byte is a group of bits. So usually, not usually, it is 8 bits. So a bit on and off, a byte, it's not an apple, that's a bad joke, but it's literally a set of bits. So a bit is the most basic unit of measurement in computer technology. So it's literally either true or false, binary, which is what we've covered before when we've done the math, and it's commonly shown by using ones and zeros. So it's either on or off with those zeros and ones. So a quick little video here, which is really handy, goes through how the bits and bytes sort of work. So when we think of a bit, we're already hitting it here with a light. So it's either on or off. And then we need to sort of go from there.
Related to computers. What is a bit? What is a byte? And what is the difference between them? Did you ever ask yourself how computers can store your photos, your videos, your documents, and your favorite games? Or how it can manipulate or send them? The answer to that is so simple. As we all know, computers are made of electric components, which obviously work on electricity. So there is only two states for electricity, on and off, or commonly used as 1 and 0. These 1 and 0s are the only two information a computer can
A common thing
understand,
people use is green
manipulate,
for
or
on,
store.
red for off.
So all the files on your computer are stored as a bunch of zeros and ones. Each one of them is called a bit. A bit, or a binary digit, is the smallest unit of storage in computers. It can just take one of two values, 0 or 1. Since you understand what's a bit, you can now easily grasp what is a byte. A byte is just a unit of data that is made up of 8 bits. To differentiate between a bit and a byte when typing, we commonly use a small b for bit and a capital B for byte. There is a common ploy often used by some internet service providers. They write in their announcement the speed of internet they provide in bits instead of bytes. For example, to show you a fast speed, they type 16 megabits per second, which is not equal to 16 megabytes per second, but only to 2 megabytes per second.
That's happened to me.
By the way, you can divide by 8 to go from bits to bytes, and vice versa. Let's see this real example. Here, here the speed provided is 4 megabits per second. That is equal to 4 over 8, which is equal to 0.5 megabytes per second only. Now, as you know the difference, you can easily spot any flaw you face and avoid being scammed.
Pretty cool. So like you talked about there, the bytes, basically what happens is a byte is 8 bits of data, and it can represent a number from 0 to 255. So a byte can also represent a character, which is what we saw before in ASCII when we did those 8 bits from 0 to using zeros and ones. So A in ASCII is represented in binary by this number, which is actually the numeric form of 97, which you should be able to do now because you should be able to look at that and go, there's 64 plus 32, no 16s, no 8s, no 4s, no 2s, and a 1. So 64 plus 32, and then add on 1. So 64 plus 32 is 96, and then plus 1 gives you 97. Pretty cool. So if we go through and add all those together, you have 1 plus the 32 plus the 64, and then nothing on the end there. So the size of a byte, there's a whole heap of different prefixes that you can add on, which comes back to the standard ones that you've done before. So how many meters are there in a kilometer? You should know that's 1,000 meters. How many grams in a kilogram? Again, 1,000 grams. How many bytes are there in a kilobyte? Well, it's 1,000 bytes. Now, there was a bit of confusion here in the past, which actually got changed. I think it was around 2004. It used to be on powers of 2, but the new system came through, and now it's based off exactly the same metric system. So to convert between bytes to megabytes, terabytes, gigabytes, etc., you just literally have to use the prefix. So kilo means 1,000, mega means a million, so M and M, giga means a billion, and tera means a trillion. So many bytes are there in a megabyte? Well, there's a million bytes. Or there's 8 million bits. That's another way of thinking about it. How many bytes there in a gigabyte? There's a billion or 8 billion bits. So some of the primitive data types, they're all the building blocks that we use. And these are the data types that are going to be used inside of Python. So broadly speaking, there are 3 different categories. There's numbers, there's letters, and then finally there's booleans. So either true or false. So why are there different primitive data types? Well, they save memory. So that controls the way that the types behave. So for example, when we add 2 things together, that has to work in a different way to when we times them. You wouldn't, and then I always use this analogy. So you wouldn't dig a trench with a spoon, which you could. And similarly, you wouldn't eat a bowl of ice cream with a shovel. So the way that the data type works is it efficiently uses the memory that you need to be able to do the job that you need to do. So the good news in Python compared to other languages that are out there, it handles it all for you. So the appropriate data type is all worked out by Python behind the scenes. And this comes from a thing called duck typing. So this is a common sort of computer science term. And basically, if it looks like a duck, swims like a duck, quacks like a duck, it's probably a duck. So generally, this is the way that we would do duck typing, which we also call dynamic typing as well. So how do you find out a type? It's pretty easy. Inside Python, you can literally type in the type and then just put in the variable, and then it will determine if it's an int, a float, a string, or a boolean. So if you ever wonder what it is, just use the type function. You'll see that it'll also change inside of idle. Let's try to open it up. So if I go x is equal to 6, and then I want to see what type this is of x, and press enter, it then tells me that it's of an integer type, which is what int stands for, which means a whole number basically. So simply putting the variable inside the brackets will see what type it's being cast as. So for numbers, if we unpackage that, we're going to go do a little bit of math here. So there's a horned lizard is an animal. It's also a reptile, a lizard, or a gecko. So these are all the different subsets that sort of wrap it all up. So it can be an animal, it can be a reptile, it can be a lizard, and then it can be a gecko. A similar approach to this has happened in our number system. So our number systems have natural numbers, which are basically all the numbers from 1 and up and counting up by ones. So all the natural numbers literally go from 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to infinity. Our whole numbers then work a little bit different. They include all the natural numbers and 0, right? So that's all the whole numbers there. Then on top of that, you have a thing called integers, which are all the whole numbers and the negative versions. So it includes 0 and goes all the way down to negative infinity, but they have to be whole numbers, right? Which drops all those. And then the last type is you have rational numbers, which are basically any number that can be written as the division of two numbers, which are pretty much all the decimal numbers that you can think of. For computers, we need to really think about integers and rational numbers. So integers are just stored as integers. Rationals is a little bit different. They actually call them floating point numbers or floats. The reason for that is the floating point number or the decimal point shifts around based off scientific notation, okay, which you may have seen before. So numbers in Python, they've got many data types, but broadly speaking, there's two main types. So there's integers, which are non-decimals or whole numbers, and floats, which are decimals. So this is done with the int and the float type. So have a go at that. Try and see what values are. So put in X, Y, and Z and see what the output is. So just pause the video, have a go yourselves. Awesome, so let's have a go. So we'll go X is equal to 10. Now we'll go Y is equal to 12, and then Z is equal to, I think I made 17.2. So sorry, that shouldn't say print, it should be type. So if we go type of X, because it's a class that, this might break it. But if we go print X, Y, you should see that they store them as whole numbers. Then if we go print X, comma, Y plus Z, what will happen then is we'll have an integer and then a floating point. So see how it's expanded the original number? So Y was used, but then it got changed into a floating point number. And then if we go print X divided by Y, comma Z, you'll see that there's two floating point numbers that get stored, which is kind of cool. So Python will automatically change the data type based off whatever you need to sort of adjust to match what needs to happen. The next one then is you have letters. So letters follow the same thing. So we call them characters inside of Python or strings. So how do we get the computer to know if it only knows zeros and ones? Well, the answer is ASCII and Unicode. So ASCII is what we've done before for all the European letters with lowercase, uppercase, punctuation symbols, and spaces and all that. So when we did A was equal to 97. But Unicode's a little bit different. So Unicode, ASCII stores all the numbers from 0 to 255 with various Latin characters. Unicode extends on that. So it stores up to over 1 million different characters. So we're using 4 bytes. So it takes a little bit more memory, but then the advantage is that it does more exotic characters. So for example, Chinese characters, Greek symbols, Korean, it has all the different characters that are available on the planet. So Unicode has all the ASCII, and interesting enough, the same character codes work exactly the same between them, both of them. So 97 in ASCII is exactly the same in Unicode, but it allows to extend on it. So Unicode has every single letter available. And if you want a full version, there's a couple of links here. My favorite one's this one. It's a little quick YouTube that goes through and actually shows every single character. So it takes 33 minutes to go through every single Unicode at that pace, which is pretty intense in my opinion. Cool. So you also can use the emojis as well. So here's a quick little ASCII chart. Interesting enough, the original codes at the start don't necessarily match up with the letters because they were used for networking principles. On Windows machines, you can actually use the Alt key and type in these codes, and then we'll automatically put in. So if you hold down the Alt key, type in 97, then release the Alt key, it will actually print out an A for you, which is kind of cool, bit nerdy. And then also all the Unicode characters as well. So there's a few other characters that you can put in to test out. So this is a little bit of cool stuff. So some people love doing ASCII art, where they use letters and then try and convert the words into art, which looks something like that. Or you can do stuff like that as well. A lot of forums online and Discord servers and whatnot uses this as well. And basically it stores the characters as the data structure known as a string. So a string contains one or more characters and then binds them all together. So when we look at the letters and words, Python uses the string data type for all of them. So they don't actually have a character data type, they're all strings. And the way that we write it is with either a double quote or a single quote. Historically, usually the double quote is used if it's more than one character, and a single quote is used for an individual character. In Python, it's a little different. Double quote means that you can change the string, whereas a single quote means that you cannot change the string. Personally, I always use double quotes when I'm writing the strings. So, for example, if I want to do hello world like we did at the very beginning, remember how the text turned green? That's the other way that you know that it's a string. So if you typed in 3 with quotation marks around, it would store the string version, not the numeric version of it. So you need to be mindful of that. Another way of thinking about it, I think of those old party signs and imagine the little invisible string that sort of goes through and connects all the words together. That's another way of thinking of why it's called a string. So it strings the characters together. So have a go at that. Make x equal to 5 and see what happens with the following outputs. Pause the video and have a go. So here we go. So we're going to go x is equal to 5. We're going to go print x, print single quote x, which should do the same. Print x, which should then give us our 5. Print x plus 1, which should give us the string x plus 1. Print x with a single quote plus 1. It's going to give us an error because it's not an integer, so it's not able to add on 1. Then we go print x plus 1. Same thing, different data type, so it's not able to do it. And then at the end, if you want to do x plus 1, it'll print that out. So one really cool thing you can also do, it's a bit of a side note, if you go x, see how it's got the 5? If I go x times 10, and then it's able to work out that it's got that plus on it. But if I stored the string 5, and then I times that 10, it'll put 10 of the same characters all in a row. So if you do cat times 4, it'll then put cat together, which is kind of cool. So this is the way that the different data type uses the operation compared to when it's an integer, which is kind of cool. So those are some of the things that you can do in here. The next part we need to go through is Booleans. So Booleans are the true and false statements. So basically they measure the truth. So Python uses Boolean data types for logic statements. It's named after George Boole, who defined the algebraic system of logic in the mid-19th century. They only got 2 different values. It's either true or false, which makes life very easy when you're trying to work through this. We'll use Boolean data types for the different control structures, which will be coming up in the coming weeks. So whether or not you use if statements or loops, you use basically true and false to get that across the line. So your turn, have a go at that. So make the following program, pi is equal to 3.14159, print pi is equal to that, and then print or 3.14 at the end. So we'll just open up idle again. So we'll go down here. We'll go pi is equal to 3.14159. And then we'll go print pi equals comma pi. And see how that interpreted it? So then it changed the string and bound on the number at the end. Then if I go print or 3.14 comma for short. What happens when you use these commas? It automatically puts a space in between, which is pretty handy. So the print statement, basically you can put in multiple values and it will output it and fix it all up for you, which is pretty cool. The other way that we can do it is you can do the compound interest rule. So given a compound interest rule is a is equal to p bracket 1 plus I to the power of n, we can create a set of instructions to find a based off this data here. So pause the video, have a go and see if you can do it yourself. Fantastic. So let's have a go. So I'm going to go p equals 1000, I equals 0.04, n is equal to 8, and then I'm going to be a bit different here. I'm going to go the final amount is equal to the principal times 1 plus I to the power of 4. And then I'm going to print out a. Whoops, sorry. A equals P. A little bit too confident then, wasn't I? 1 plus I star star to the power of n. And now I'll print out A. There we go, that's better. So as a good computer scientist, it stored a really long number with all the decimal points, which wouldn't necessarily work because remember it's a dollar value that's coming out. So we probably need to round this, which is great. So in Python, there is a rounding tool that you can use, which is super easy to use, very simple to follow. And basically all you got to do is follow these steps. So how can you use the round function? Pretty simple. What we do is we go round, you put the first number, comma the second number. So number 1 should be the value that's going to be rounded. Number 2 is the number of decimal places that you want it to round. So for example, here, if I go round, brackets, and then the first number, 6.4543, comma 2, that will then output 6.45. So we'll round it down to the second value. So with this one here, if we come back to it, we go, let's go print, and you can put a function inside of it. So we're going to round a to 2 decimal places. How cool is that? So Python's now handled the rounding for us, worked out all the math, and then actually done that all by itself, which is very, very useful, particularly when you get more complex things along the way. So some conclusion questions to think about. How would you explain the difference between ASCII and Unicode to a friend that knows nothing about programming? Can you think of a real world situation where choosing the correct data type is crucial? How might the concepts of variable naming and data types apply in other programming languages outside of Python? So think about those things that we've covered. There is a Kahoot at the end here that you can sort of play, which is a bit of fun. And then there's also the Holy Python exercises that I would recommend having a go at. They're really good because they give you hints along the way and also show you the solutions. So that's it from me. Hopefully you've learned a little bit about data types. There is a lot in it and it's really, really useful. Please make sure that you try and get your head around the difference between a string, an integer, a float, and then a Boolean. It will make your life significantly easier when we get to the more harder stuff as we go. So thank you very much. Hope you've enjoyed. See you next time on Steam It with Steve. Adios.